lines, and we have two great speakers here who are very active in our expert groups, David Bouchard and Carsten and David. And they're combining two of my favorite topics. My team at IBM works on OpenWhisk, and being part of the OSGi Alliance, I guess I care about the other subject as well. So I'm going to turn it over to these fine gentlemen to walk us through smart IoT on OSGi.
Okay, yeah. Thanks, Dan, and welcome to our session. So I hope we will have some fun in this session with IoT today. During the last 2 or 3 years, David is always coming up to me and saying, "Hey, I'm doing IoT," and I think the impression on my face is a little bit like this. It's not that severe, but so in this talk we want to show a little bit what you could do to get started doing IoT with OSGi, and especially with maybe using Apache OpenWhisk. So, yes, that said, my name is Carsten Ziegler, working for Adobe, participating in the OSGi specification groups. I'm also currently the VIP, or the VP, not the VIP. Apache Felix and Apache Sling. VIP would be nice. Next to me is David Bouchard, my colleague working for Adobe from Ireland. He's the chair of the Enterprise Expert Group, very enthusiastic about open source, cloud stuff, and IoT, of course. And so I guess let's get started.
All right. Okay. Thanks, Carsten. Yeah. So this talk is about IoT and OpenWhisk, but I'd like to start with just talking about the IoT part of the equation and how you can implement an OSGi application, an IoT application using OSGi. And there's a lot of people who kind of do demos around this stuff, and maybe they fall into the idiot category. So whether I'm an idiot, still an idiot or not, I guess I'll leave that to you to decide at the end of the talk. So let's say you have a bunch of IoT devices in your smart home or in your industry, and they're all connected in some way, and you want to kind of do something smart with those on the back end. How do you get there? How do you achieve that? That's kind of the question that we're kind of looking at. So first of all of these devices typically have some sort of specialized protocol, right? In most cases, your IoT devices have wireless protocols that are specialized for a particular purpose. They might be low power. They might be specialized to go through thick walls because that's what in your industry typically happens. Or they have some other specialization. There's some standard like Z-Wave or ZigBee. But the I in IoT doesn't really apply because these devices are actually not on the internet, right? They all are typically in some sort of a local network. So really, to make it an IoT device, you have to connect it to the internet, and you have to do that via some sort of a gateway. We think that OSGi is great for that, because OSGi is a unified open platform that you can add your own functionality to it, but it also comes with a bunch of functionality. It's like an application server, but then tiny, without all the bad baggage that you might get with other containers. OSGi has a service registry, which has been proven to be a great integration point between loosely coupled entities. OSGi defines some specific IoT APIs, and I'll get to those in the next slides. From historic perspective, OSGi has been proven to be a great place to reuse and share libraries, bundles, capabilities, implementation. So that's a great thing you have with OSGi as well. And obviously there's quite a lot of tooling available if you want to do provisioning, for example. And finally, OSGi is great to be dynamically updatable. So that applies both to the drivers that you might have in your framework for your hardware, but also to the topology of your system. At runtime, your system might change. You might have just bought this fantastic internet-controlled extractor fan. You might want to make it part of your system. The dynamic nature of OSGi makes this really easy. It's really built for this kind of dynamic situation. So the first thing I wanted to do was basically take a closer look at some specific APIs that OSGi defines for the IoT world. And there's a bunch of, actually there's 2 specifications in the OSGi specs called the Device Abstraction Layer. They have slightly different names, but they both relate to the Device Abstraction Layer. And this specification gives you an OSGi services view over your devices that is abstracted from the underlying details of the technology. So let's say you have like a radiator thermostat like that one, like I actually have that one in my house. It's a Z-Wave based one. If you kind of connect that via DAL into OSGi, you get a bunch of services. And there's two different types of services. There's a device service, there's one per device, that basically just tells you that the device is there. It gives you some other information, whether it's on, and I think you can find out what the make of it is and the model or something like that, but it's mostly type of a presence service. And then the DAL gives you some other services that are functions. And the functions, one device can have many functions. My particular radiator thermostat has two functions. It allows me to set the temperature, so that's this function, a temperature control function, that allows me to say, okay, I want it to be 18 degrees. And I call that on the function. I look at my radiator thermostat, a few minutes later, it goes to the set temperature. Usually there's a little bit of a delay with these things, because they don't want to spend all their battery all the time being connected to the network. But there's another function as well, which is really handy. In my case, it tells me when the battery is low. If you have your house full of smart devices, they're typically powered by batteries, and you don't want to have to open them up every now and so often to check that the battery is okay. So most of these devices tell you this information as well. So that's another function. So the DAL is device independent, and besides these functions, it also gives you event admin support. If you have something that you want to read out of your device, whenever that changes, it sends an event through event admin through your system, so you can pick it up via event admin. So just to give you an idea of the things that the DAL supports out of the box, it has a bunch of data types like alarm, Boolean read and write functions, like keypad, meter, like it's a multi-level read and write function, so typically a numeric value, a wake up function, you can poke the device to wake it up. But you can also make your own data types. These are just, that you get out of the spec. And there's a whole bunch of services that are, functions that are defined. These are functions or services for the typical devices that you might find out in the world. Like, humidity sensors, motion sensors. You can have like a light function that allows you to kind of change the light color for your smart light. Or a window function that allows you to open and close your window blind, and that's all kind of that you get as well. So we thought that this would be an interesting basis for a nice demo. And so the first part of this demo is really just going into OSGi. It's not using the smart backend just yet. And what we have here is we have a little setup where we run OSGi on this old Raspberry Pi that I have here. And we have some smart radiator valves. There's one here, and Oleg will show on there. There's one there. These ones are actually a little bit modified for the demo because the real radiator thermostats aren't really that visible from the outside. So I put some LEDs on there that show you when they're on or not. And then I have a bunch of I have two motion sensors here that basically tell the system whether there's motion. So the idea is that we're saving energy because we only switch on the radiator when there's somebody in the room. When somebody walks out of the room, the radiator is switched off again. So it's an eco-friendly demo, I would say, and it might inspire you to build something like that in your house to save energy. Okay, so before I actually show the demo, I just wanted to quickly show you how this works in terms of OSGi. And how simple it is to work with these devices using DAL. This is just a little bit of code that is written using DS, and it really shows you that you can use these services for everything. So I have this component, which is an event admin event handler, and it simply is subscribed to the topics, the property change topic of one of my motion sensors. So whenever there is motion detected in the motion sensor, the handle event gets called. And then I can do something. I obviously want to control my radiator, so that's the function that is injected here.
I basically select my radiator function from the service registry using this reference. And then once the event comes in, I obtain the multi-level control API from the function. I check whether there's motion or not, and when there is motion, I set the temperature to 21 degrees. If there's no motion, I set it to 7 degrees. So that's kind of, you know, how it's done and how simple it is. Obviously, I could have used the new component property types at the top for DS. I didn't do that yet, but that would make it even nicer to look at.
You could have used the converter to get your event property.
I could, yeah. Yep.
It's just a demo.
Okay, so let's do the demo. Oleg, if you would like to hold it up. Basically, Carsten will walk from one place to another. Now, these motion sensors are a little bit tricky. Okay, so let's see. Okay.
So basically, for the people sitting in the first 3 rows, just freeze.
Yeah, just freeze. Okay.
Motion sensor.
Okay, Carsten, you want to start walking?
Yeah, I do my best to what I can do.
Heat is on.
Okay.
Just because of me, yeah.
Right. Great. Okay, so that's a really simple kind of. It's a really simple kind of directly kind of dumb IoT application that runs directly on the gateway itself. There's no smarts in here, and I think the next part is going to be how you can make it smarter using backend technologies.
And by watching this demo, you could see who of us is the idiot and who's doing the cool stuff. All right, so yeah, this was this nice demo. Just again, the setup of how it is right now. But now you obviously want to have some smart logic in the setup, because turning on the heat just because someone is entering the room might A, not make sense, or B, is way too late, right? Because it takes some time until the room is actually heated up. So let's see how could we do that. And before we do that, let's see a little bit of history in infrastructure or deployment of stuff. Back in the old days, everyone was taking care of the servers where stuff was installed, of the operating system of the applications and so on. Then virtualization happened, where you had your VMs to use to deploy your stuff. And since some years, we have the container principle, concept, whatever, with Docker being the most famous solution to do that, I guess. And since some years, we have something, let's say, new, or at least a new buzzword, which is serverless. So this is actually here misspelled, I should say serverless. Prominent examples are Amazon Lambda or the Microsoft Azure equivalent, where you just deploy a function, like some JavaScript thing, and whenever you invoke that function, it gets executed. But you don't have to take care, set up a server or even a container or whatever to run that stuff. That function really just runs whenever it's invoked. So the idea is to reduce cost by not having a running server. And this basically gives you function as a service, or FaaS, which I think is a nice acronym. And this function, as I said, is triggered by some event, invoked, does something, and it can scale as needed. So if the function is more often invoked, it scales up and down. And the idea, as I said, is to reduce your costs in the end, because you don't have to run that server the whole time. It just spins up something that executes your function whenever it gets executed. That actually makes sense for a setup like this, where the events that are occurring, like people entering a room or leaving the room, are only very sparse throughout the day. Unless you were very productive, have a lot of kids at home, then they are running around the whole time and running from one room to the other. But in general, it only happens, I don't know, 10 times a day. And if you don't want to use an existing provider like Amazon or Microsoft, you could also use Apache OpenWhisk and deploy OpenWhisk in your own data center or wherever you want. And it basically gives you a serverless infrastructure. So once you have OpenWhisk running, you can deploy your functions. This could be JavaScript or a different programming language. You can even deploy Java functions in there, and then you can execute them. It's usually a REST interface which you just call to invoke a function. There's also a command line you can use for testing or deploying stuff, a nice UI, and then all these things. An interesting thing, you could also chain those functions, right? So you invoke one function, that function invokes another function, and actually that function can use a totally different programming language, just to confuse all your colleagues who have to maintain that stuff. So that's the basic setup of OpenWhisk. Really allows you to have a serverless infrastructure within your own data center or wherever you want to run it. So how does it help us to get some smart logic into this nice setup? Well, we use another buzzword of the year, which is you can use machine learning and do something fancy with that. So we have on the left-hand side what we have here as a setup. We have this nice gateway with the DAL, with the device abstraction layer. We have our motion sensors. There might be a sensor checking the temperature outside, and it might give you the time when someone is entering the room. So whenever someone enters the room or leaves the room, this event is posted to OpenWhisk, where we have deployed just a simple function that stores this information into a database, some persistent storage. And that function actually invokes another function, which then kicks off the whole machine learning stuff and has all the logic in it. It creates a prediction of how long that user will be in the room and when he might leave the room. And then you can use that information to decide whether you have to turn on the heating or not, because the user will just be in there for 2 minutes. It doesn't make sense to heat up. Or it could be a prediction like you always know that, or you know that the user or the owner of the home is entering that room every day at 8 o'clock, so the system turns up the heating at 7:30 or something like that. This can all be done nicely with machine learning, and that's actually the second function you have running in OpenWhisk, the prediction thing. So the gateway gets the prediction on when to turn on or turn off the heating. And as I said, for this kind of setup, serverless makes sense, as these events are really very rare throughout the day, and you don't have to have the server running the whole day. Reduces the cost. And I guess, are we doing the demo now or later?
There is a demo slide.
I'm totally confused by the heat.
There is a slide that says demo. I think there's nothing on it, so it's a little
okay.
bit later.
It's later.
I think so.
I wanted to do the walk again.
Let me just check.
So, right. So this is the one way of doing that stuff. And the nice thing of combining this now with OSGi is you can actually decide where you want to have these functions running. It could be in OpenWhisk, that's one solution. But you could also just run this prediction service if it's small and doesn't need that much calculation power in your gateway. Or you can move it out to a remote OSGi framework and use OSGi remote services to invoke that thing. That framework, of course, can run in the cloud. Or you're going one step further and actually have OpenWhisk running, and inside OpenWhisk an OSGi framework which does these things. And you're still using remote service calls to do that stuff. So basically, whenever an event is triggered by the gateway, this function is invoked in OpenWhisk, and this function actually starts up an OSGi framework and invokes a service with a method in it and returns the result. That basically allows you to move that service wherever it makes most sense. And you can do these nice things with OpenWhisk as well. But maybe you just want to deploy a JavaScript function. It depends on how you want to set up your stuff. This basically sums up the nice advantages of OSGi and using a serverless infrastructure on the backend. And this gets us to the second demo now, right?
Yes, I think so, absolutely. So what we're going to do now is we're going to make it smarter, and first of all, for that, oh, I can see that here. I guess it might be worth stopping the sharing and showing you this lovely screen. But this is basically my OSGi framework that runs in the Raspberry Pi. And as Carsten said, it uses an OSGi service, a remote service, to talk to the smart backend. So currently that's bundle 3, it's actually not enabled. So I'm just going to enable that service by starting that bundle. So I'm starting bundle 3. So that's the change I'm making now. The smartness is enabled in the gateway. And okay, so let's see if it works. And basically the idea is that instead of switching off immediately, the system is smart enough to say, okay, well, I know that this person is going to stay a bit longer in the room. Let's not switch off the radiator heat straight away. So Carsten and Oleg, if you would do the honors again.
Start from left to right.
Right. Okay. So let's see. Okay.
Just to confuse you.
Okay, so that's the minimal smartness that we've achieved. The heating stays on, but I mean, this is kind of the start of, as you can see, you can make it even more interesting than that. But it just shows you how you can, thank you very much, Oleg, thanks, Carsten. It shows you how you can use OSGi services to enhance your system and to grow it out, to talk to the serverless backend, such as OpenWhisk. Or something like it. And I think that's the conclusion of our presentation. Go have fun with stuff like this. Any questions?
Are you running OpenWhisk on your Mac?
No.
No. That was just an example.
Yeah.
The principle. Okay.
I mean, you can run OpenWhisk on your laptop. It kind of works, but it takes a lot of resources.
Right. Yeah.
And we didn't want to have an internet connection here for the demo.
I understand.
But I mean, OSGi is fully running here. It's just a standard Felix framework. And this is an old Raspberry Pi. I've got better ones, but they're actually in use at home. But it just shows that you don't really need, I mean, you can do this stuff with really cheap hardware these days. I mean, you know, we're kind of just hobbyists. On the other hand, in the OSGi spectrum, there are specs there that help you. So whether you're a hobbyist or you're a professional, these standards help you define APIs and making it simple to create an interoperable system that allows you to you know, connect together your IoT devices. Christian.
Do you have working connections to Z-Way or whatever you need as protocols? Is that already available, or is it just the specs and you implemented the connection yourself?
I implemented these myself, but the specs are so simple that they're really simple to implement. They basically just require you to service functions, to service services that are functions, and so for any protocol it'd be really easy. Obviously, it would be great if the industry vendors would provide these drivers themselves. That would be even easier when you buy some sort of a device in the shop or on Amazon that you can download a bundle for it. I didn't really investigate how much of that is available, but these specs are developed by, you know, in the Alliance, but mostly driven by telcos like Telecom Italia and Deutsche Telekom, so that's where they come from.
So there's probably not open source drivers available.
I haven't checked.
I guess they do their own thing.
I haven't checked, but yeah.
But on the other hand, I mean, in this demo we use the abstract device layer to do that. If you want to use an already huge existing base of drivers for devices, you could also use Eclipse Smart Home things where are drivers for, I guess, nearly everything which is out there today.
So what kind of machine learning do you think you would need and just running your gateway?
I mean, for this kind of setup, like the machine learning is not really having to do that, right? The functions not. And to your question, I guess, I mean, you still need a gateway to talk to the machine learning part, unless you want to run the machine learning part in the gateway.
I guess it depends a little bit on whether you have one gateway that controls everything, or whether you have many gateways and it becomes infeasible. If you want to have like a big data mining, functionality available as part of this prediction, then it probably is not feasible to run it on your Raspberry Pi. In our little example, you could probably run a neural network on your Raspberry Pi if you really wanted to, but I mean, I guess that doesn't really scale that well.
Any other questions? Well, thank you.
Thank you.
Our next session is going to be